Right. Good evening, all. Shall we start? Uh, can you hear me properly? Can someone confirm whether I'm clearly audible now? Am I audible? Please confirm whether I'm audible or not.
Yes, sir, we can hear you.
Very good. Thank you, Rana Singha. So let me start the lecture. So, actually, I was planning to. Uh, I was planning to record this lecture and put it into the VLE, but Sanoka requested to have this final lecture through online. Right. So I decided to conduct this lecture. So this will take around less than 1 hour actually. And I need to give you some guidelines, some information regarding your final exams as well. So did you receive any timetable for your exam? I think not yet. Shortly you will receive the exam timetable, I think. Anyhow, so first, let's start the final part. This is the missed part of automobile technology lecture series, steering system. So basically, I'm going to discuss about basic purpose functions of the steering system and main parts of the steering system and basically power assisted braking part, both the electric and hydraulic power steering systems, right? So that is the scope of the today's lecture. And so this is the purpose of automobile steering system. First, we are going to study about the steering system, then power assisted steering system, right? So that is the lecture flow. So, main purpose of the steering system, as you all know, to control the vehicle's direction by changing the uh, angle of front wheels or rear wheels or both, right? Hope you all are familiar with the front wheel steering system. So that is the most common configuration in available automotives and heavy vehicles, right? And I think some of you have seen rear wheel steering system, especially in loading machines and forklifts, right? And some sort of heavy vehicles. And uh, both front and rear wheel steering systems, so much more common in vehicles where it need to be rotated in limited spaces, especially ambulances having both wheel steering systems, so they can maneuver the vehicle in very compact locations, right? So ultimately, when it moves from rear front wheel steering system to both wheel steering systems, the turning radius of this vehicle has been greatly reduced, right? Especially, actually, the vehicle can be rotated at a single point, right? So that is the major advantages when it moves from front wheel steering system to rear wheel low both wheel steering systems. So, and additionally, we have secondary functions of steering system. So, as I said earlier, the vehicle can be manual or vehicle can be the direction can be changed using the uh, steering system as per the driver's command, right? So the driver can control the vehicle's direction. And the second point is the steering system can provide the stability to the vehicle, right? You all know that whenever automobile takes a car takes a turn or when it takes a bend, so that the the along with the suspension components, the steering system will increase the stability of the automotive. So you know that whenever and sometimes you have seen this behavior. So whenever vehicle overturns or oversteer, the situation can be handled by using change in the steering angle. Hope you all have seen, right? So even in the rally racing or some sort of accidents like oversteering situations, the steering system or the steering wheel does a crucial job to maintain the stability back in normal, right? And additionally, you know that the gyroscopic effect, you know that gyroscopic effect means whenever the wheel or the inertia wheel rotates at a higher speed, so that the combined system will maintain the exact uh, direction, right? So due to the gyroscopic couple, which means when heavy mass or heavy inertia rotates at the center, so it will maintain the rotation and the moving direction without any changes, right? So that is the gyroscopic effect. මොකක් හරි අපි හිතමු wheel එක කියලා wheel එක කියන්නේ heavy mass එකක් ඕක වේගෙන් කරකෙද්දි ඔය එන ගයිරොස්කෝපික් කපල් එක නිසා එයාගේ ඩිරෙක්ෂන් එක චේන්ජ් කරන්න නැතුව ඒ මොමන්ටම් එක දිගටම තියාගෙන ඉන්න. So that gyroscopic couple will also increase the stability of the automobile. Right. So then third point, it minimize the tire wear and tear. You know that whenever we take a bend, by changing the angles, turning angles of the front wheels or rear wheels, we can simply turn the vehicle. Otherwise, wear, uh, it will increase the tire wear, right? Later I will show you the different turning circles, different turning angles in automobile steering system. Then you will understand that how the steering system reduces the tire wear, especially, right? Then fourth point, it prevents road shock from reaching to the driver with the support of suspension system. Actually, suspension system and the steering system, uh, it's a kind of collaborative systems, right? So without the steering system, suspension cannot operate efficiently, and so that it also increases the stability and maneuverability and the handling characteristics of the automobile. So these are the secondary functions of a steering system. So this is the thing that I told you during the third point, right? So whenever automobile takes a turn or bend, all four wheels, suppose we have four wheels, all four wheels are taking different circles, right? So different circles. So you can see that. So these are the rear wheels, right? Rear wheels supported on a lead axle, let's say. So this is the inner side, outer side, and these are the front wheels. Even the front wheels are taking different turning circles. And especially you can see that these front wheels are having different angles which are projected in the center, right? So these angles are different whenever it takes a bend or turn, right? So by maintaining these angles, by the use of by using the steering system, the tire wear will be reduced, right? Otherwise, suppose these both wheels or both tires are having same angles. Suppose these lines are parallel, so then tire wear will be increased. So these are the secondary functions of a steering system. And also, I need to mention that our differential, the differential effect also helps to maintain different speeds because each wheels are having different turning speed or wheel speeds, right? So the differential is also supposed here to maintain the correct stability and the correct direction. Here you can see some sort of extended graphical image which indicates different angles, right? So that's all. And when we discuss about the steering mechanisms, so there are a lot of, right? There are a lot of, but under your curriculum, we are going to study about this recirculating ball steering gear and track and pinion steering gear, right? So based on the vehicle manufacturer and the applications, there are a lot of steering mechanisms, but compared to others, rack and pinion is the most common, and recirculated ball steering gear is also pretty much common in heavy duty vehicles, right? So I selected these two to further discussion. And initially we are going to discuss about this mechanical steering systems. So that I have divided the system into three main parts: steering linkage, and the steering gearbox, and the steering column and the wheel, right? So whenever we discuss about the steering linkage, the most primary is the parallelogram steering linkage, where our components, the rods and the connecting links are creating a parallelogram. Yes, so that is why we call it parallelogram steering linkage, right? So when we deeply uh, focus on the system here, the configuration here. So you can see that few common components are here, also here. Here we have our pitman arm, and which connects the center link to the steering gearbox. Here we have a steering gearbox, which that part is missing. Our steering wheel is directly connected to the steering gearbox, and the steering gearbox output shaft is connected to this pitman. Pitman arm is connected to center link to the tie rod ends, both inner and outer tie rods. And the outer tie rod end is connected to the steering knuckle, right? The steering knuckle is connected to our wheel hub and tire and the rim, right? So that is the configuration in parallelogram steering linkage. So these are the basic components: pitman arm, our center link, and we have idler arm to support the pitman arm and the center link, just to support the motion transmission. And we have our tie rod, and the outermost tie rod is called outer tie rod, and the inner side and is called inner tie rod, right? So these are the main components actually. So and here you can see pitman arm from the first figure, and the idler arm and center link. So these are the actual images. Uh, and the steering mechanism is bit, bit uncommon nowadays, right? So this parallelogram steering linkage. So nowadays we have rack and pinion steering system. So this is the most common steering system which we have in lightweight automobiles, right? So rack and pinion, you know that rack and pinion is a power transmission uh, component, right? Rack mean straight gear, and pinion means a circular gear, right? So when the circular gear rotates the top of the rack, so rack will undergo a linear motion. So pinion is experiencing a rotation motion while rack is having linear motion. So that mechanical component have been used in a steering system. So that is the rack and pinion steering system. So the steering input is received from a pinion gear, then rack slides in T. So converts rotational motion of the pinion of the steering wheel into a reciprocating motion of the rack. Right? And the tie rods are the only steering linkage part used in a rack and pinion steering system. So inner end is connected to the rack side, and we have outer tie rod end connected to the steering knuckle. So the movement of rack pushes and pulls the tie rods to change the wheel's direction. And at the tie rod end, we have a ball joint, so that the ball joint allows the uh, some extensive motion of the steering knuckle. When the steering wheel rotates, the steering shaft rotates, pinion gear rotates. When the pinion rotates, rack moves left or right based on the requirement. Tie rods move, right? Tie rod end is connected to the ball joint, right? Through the ball joint, the steering knuckle rotates. Then the steering knuckle means uh, it is the whole tire and the hub system, right? So that is the working principle of the rack and pinion steering system. So this graphical image shows you the major components, right? So as I said earlier, so we can't discuss the steering system alone. It combines with the suspension system, right? Here you can see a MacPherson strut along system and a rack and pinion steering system. And let me start from the suspension part. Here we have our coil spring and the damper. And the steering knuckle is there connected to our tire and the rim, right? And from here in red color, red or orange, I think. Here we have our stabilizer bar, right? So these are our bushes. Stabilizer bar ends are connected to the lower arms, right? We call it control arm, but the more commonly we call it lower arms. Here we have another ball joint here, which connects the steering knuckle to the lower arm bit, right? Uh, yes, sounds issue. So let me connect with my mobile phone, right? So just give me 1 minute. Right. How about now? Sanukak, how about now? Can you hear me clearly?
Yes, sir.
Okay, good. So whenever you send the chat box messages, now onwards, please send to my laptop, right? So the account where I'm sharing the screen, right? Otherwise, I'm not going to see the mobile screen, right? Otherwise, I will miss your messages, right? So let me start from here. So I was discussing that the steering system cannot be discussed alone. That it's a combined system. It's a combined with the suspension system. So these are the major suspension components from here to here with our MacPherson strut. Here we have our steering column, sorry, steering knuckle. Steering knuckle is connected to our lower arm through a ball joint, right? Yes, and our anti-roll bar is here, stabilizer bar, or we call it sway bar, right? Not the anti-sway bar, it should be sway bar. Yes, so these are the components which belongs to steering system. Our steering wheel is here, steering gearbox is here, rack and pinion. So this tube includes the rack and pinion, and we have our uh, tie rods, inner tie rod and outer tie rod, right? Basically, inner tie rod is called as racken. Hope you all are familiar, right? And outer tie rod. And this junction, these couplings, basically junction is covered with a rubber bellow, because you know that these gears may damage when the water and dirt or dust, uh, if dirt and dust and the water ingress into the system, right? So just to avoid the water ingression and the dust ingression, the both ends are covered with rubber bellows or rubber, we call it dashboards, right? So those are the major components in suspension. I'm sorry, a rack and pinion steering system, right? Let me move forward. And when we disassemble the rack and pinion part, we can see the pinion gear, rack gear, the oil seals, mounting brackets, rubber bellows, and the tie rod ends, right? So those are the major components. So I'm not going to discuss the inner components deeply, but you should have idea about these are the this is the cover, this is the gearbox, pinion, and the rack. Why we have rubber bellows there, dust covers there. So, what are the two types of tie rod ends, inner and outer? Inner one is called the rack end, right? So, likewise. So, this is the second steering linkage system, steering gearbox system. The recirculating ball steering gear, the thing is quite interesting there, right? You can see that the green color shaft is our input shaft, right? And the this blue color one shaft is called sector shaft, or we call it our output shaft, right? Our steering column, our steering wheel is connected to this input shaft. So what happens when we rotate this green color input shaft? What happens? So this shaft rotates. These balls starts recirculating. Then this bearing, we call it kind of ball bearing, recirculating ball bearing, will move along this shaft, right? So this is a kind of lead screw, right? So this is a kind of lead screw. Whenever this shaft rotates, this recirculating ball bearing will move along this shaft, right? Then, so you can see that there is a gear mechanism. So, following the gear mechanism, this output shaft or sector shaft will rotate, right? So, this output is connected to our steering linkage. Then, the motion will be transferred to the steering knuckle and the wheels, right? So, that is the operation principle of a recirculating ball steering gear. So this gearbox is this steering gearbox is much common in heavy duty vehicles, right? And even in our workshop, we have EV. That EV is consisted of this recirculating ball steering gear mechanism, right? So you can see both the gearboxes in automobile lab. We have both the recirculating ball and rack and pinion steering systems in our demonstration kits. Yes, then we have a small video. So before playing the video, let me share the sound. Um, right.
Early steering systems relied on the reduction gear ratios within the steering box or rack to reduce steering input required by the driver.
Right. From this video, you can see how the rack and pinion steering system, and it clearly demonstrates how the recirculating ball steering system works, right? Say it again.
Early steering systems relied on the reduction gear ratios within the steering box or rack to reduce steering input required by the driver.
So that is the working principle, and the differences in rack and pinion and recirculating ball steering system.
Early steering systems
And it is
relied on the
called
reduction gear
as
ratios
a
within the
Warman
steering
sector,
box or rack
right? Warman
to
sector
reduce steering input
gearbox,
required by the
because
driver.
Warman sectomy in terms of gear geometry, right? In terms of gear geometry. So when we focus steering mechanism, right? So basically, we have a numerical or mathematical equation for steering ratio. It is equal to angle of rotation of the steering wheel divided by angle of turn of the wheel. Right? Suppose we have a steering linkage or steering mechanism. Whenever we rotate the steering wheel by 15 degrees, and then if your wheel rotates 1 degree, then we call it the steering ratio is 50, right? So it is the steering wheel angle or rotation angle divided by wheel rotation angle, right? So this is how steering ratio is calculated. Whenever steering ratio is higher, the steering effort will be reduced, and the handling and the maneuverability will be reduced, right? So the effort will also reduce, and the handling characteristics will be reduced, right? And also we have different gear geometries which will provide constant steering ratios and variable steering ratios. And so this is the input section, which consists of our steering wheel and the steering column and the universal joints, right? So the main purpose of the steering wheel is to detect the driver's input and send the driver's input as a twisting force or torsional force to the steering gearbox, right? So these are the major components and the functions. And here I have mentioned the main functions of subcomponents. Especially, I need to highlight that these universal joints will allow the power transmission in between the shafts where which are placed in different angles, right? Universal joints can transfer power in between non-aligned shafts, right? Here you can see that these intermediate shaft and output shaft steering, this output shaft is having a little angle, right? So that we need to connect these two using a universal joint or Hooke's joint. Yes, and the modern, not modern, right? The vehicles, automobiles manufactured after 2001 or 2000 mainly, having the facility that the steering angle can be changed based on the ergonomic data or anthropometric data of the driver, right? So suppose the vehicle is used by several drivers, that to maintain good anthropometry or ergonomics, that the handling devices should be adjustable, right? So nowadays we have these adjustable steering wheels, especially the steering wheel angles and the distance can be changed, right? So these steering column is supporting the telescopic movement and tilting movements, just to maintain correct ergonomics, right? Just to provide comfortable driving, not just comfortability, it will increase the handling characteristics, right? So those are the major things that I need to highlight here. So shall we move forward to the power assisted steering systems, right? So we call it power steering systems. Any question up to now regarding mechanical systems? Right. So let me discuss about the remaining part. So you know that in non-power assisted steering system, the steering effect is totally depending on the steering ratio and the construction of the steering system. So that the driver need to put some extensive effort to change the direction of the automobile, right? To avoid that, to avoid to increase the handling, to increase the stability, the power steering systems have been introduced, right? So we have basically we actually I have listed only two, but we have basic three power steering systems at the moment. So the first one is hydraulic power steering system. So that is the oldest power steering system. Then we have EPS, electric power steering system. And nowadays we have combined, right? Electric plus hydraulic power steering system. So those are considered as hybrid power steering system. Both hydraulic cylinders and electric motors are there to support. Yes, and we have common power steering systems, integral piston, rack and pinion, and external linkage power steering system. Shall we quickly go through those systems? So this is the basic operation. While the driver rotates the steering wheel, these power assisted systems may support the steering, right? Just to support the so the first part, the hydraulic power steering system. So we have basically a hydraulic pump located at the engine compartment. So mostly it is belt driven using the engine crank. So the power steering pump is there to develop the pressure required. So that hydraulic pressure is directed to the double acting cylinder. So double acting cylinder will control the direction or the angle of rotation, right? So that is the main the simply working principle of the power assisted hydraulic power assisted steering system, right? So let me show you how hydraulic pump works.
Hydraulic pump creates flow within the steering system and provides the force required to operate the steering gear. The power steering pump is generally belt driven by the engine crankshaft. This means whenever the engine is running, hydraulic flow is maintained. The most common hydraulic pump is the centrifugal vane type. Rotation of the pump shaft spins the rotor and retractable vanes inside an oval-shaped camring. Hydraulic fluid is drawn into the pump housing from the reservoir due to the low pressure created by the rotating vanes. The fluid is pushed by the vanes to the outlet side of the pump housing, where it passes through a flow and pressure relief valve before entering the supply hoses.
Right. So this is the most common power steering pump type. So the vane type power steering pump that compress the power steering fluid and send it into the flow regulator or pressure regulator valve, then to the double acting cylinder, right? So hope you all can remember that special vane type pump during our air conditioning lecture. I bought the air conditioning pump, a compressor, air conditioning compressor that had the same configuration, right? So it is also a vane type compressor, right? So hope you all can remember. Likewise, even in power steering systems, we have few other pump types. So this is the most common vane type power steering pump. Then gear type one also common, and roller type, and this is also a vane type, but the configuration is a little bit different, right? So those are the common power steering pump types. So the purpose of the power steering pump is to increase the pressure inside the system that retract the double acting cylinder, right? So then the pump outlet. Pump outlet is connected to the pressure relief valve. So it's a kind of pressure regulator. So that the pressure relief valve is used to maintain the correct pressure inside the system. So actually it is for avoid overpressure, right? To avoid overpressures inside the system, because you know that this power steering pump is driven by the engine crank. Whenever the engine speed is increasing, the pressure inside the system will be increased, right? Since there's no any clutch mechanism like in AC compressors, that it will full time rotate with the engine, right? You know that normally engine rotates from 0 to let's say 5,000 RPM, right? So in between that those RPM levels, the power steering pump will also rotate at higher speeds. Whenever engine rotates at higher speed, power steering pump is also rotates. Then the pressure inside the system will be increased. So then what happens? So suppose we are driving in the low gears under high RPMs, let's say 3000 RPM. So whenever we take a turn while having higher RPMs, the steering effort will be reduced so that it will ultimately be a reason for instability of the vehicle. අපි වංගුවක් ගන්නකොට වැඩියෙන් කැපුණොත් කොහොමද? කියන්නේ ස්ට්‍රේට් යන වෙලාවට ප්‍රශ්නයක් නැහැ. බෙන්ඩ් එකක් ගන්නකොට RPM එක හදිසියත් වැඩි වෙලා අපේ ස්ටියරින් එෆර්ට් එක අඩුවෙන් ගිහිල්ලා වැඩියෙන් කැපුණා. So ඒ වගේ දේවල් අවොයිඩ් කරන්න තමයි මේ ප්‍රෙෂර් රිලීෆ් වැල්ව් එක තියෙන්නේ. ඇක්චුअली ප්‍රෙෂර් එක maintain කරන්න. Right? Here you can see that all the ball valves are spring tension, right? Whenever the pressure inside the system go beyond the threshold, this valve opens, this ball opens, right? So that is how it works. Yes, and power steering hoses should be sufficient enough to withstand higher pressures up to 1500 psi, and the temperature is also it should be sufficient enough to withstand temperatures up to 150 Celsius at least. So where we don't need some sort of flexibility, and if we don't have any kind of relative motion, then we can use metal lines, which will provide a higher higher lifetime compared to rubber hoses. Right, then the outermost end, the power cylinder, It's a kind of double acting cylinder. The meaning of the double acting cylinder is we have one inlet and one outlet in between the piston. Whenever the left chamber is pressurized, our piston and the shaft will move to the right side and vice versa. So that is the working principle of the power double acting cylinder, right? Yes, in the case of integral piston power steering system, so our power steering part or power steering double acting cylinder is embedded into the steering gearbox, right? So let me show you. Yes, so here we have our power steering gearbox. The double act the power part, power steering, the fluid actuator is embedded to the power steering gearbox, right? So here we don't have any kind of rack and pinion or any kind of steering mechanism, power steering mechanism there, right? Yes, here another figure that shows the integral piston power steering system. So we don't have any rack and pinion there. So all the work is done inside the steering gearbox. So whenever we discuss about the power steering system, the fluid control valve does a crucial job that it acts as a sensor and actuator, right? It acts as a sensor and also actuator, right? So this fluid control valve is mounted on a small torsion bar. Let me show you, right? So this is the fluid control valve, or we call it rotary valve, which directs the pressurized fluid from pump to the here at this end we have the double acting cylinder, power steering cylinder, from pump to cylinder, then back again to reservoir, right? So this rotary valve or power steering valve directs the power steering fluid from pump to cylinder while it handling the fluid flow rate. Actually, it handles the pressure here, right? So as I said earlier, so this rotary valve act as a sensor and actuator itself. So it senses the driver's steering effort, right? So it senses the steering effort. So suppose I'm giving a little effort to take a smaller bend, so that this rotary valve is supported with this torsion bar, right? Here you can see a torsion bar. So it will measure or it will limit the amount of twisting, right? So suppose this torsion bar is fixed here and it is the other end is fixed to the rotary valve, that it can feel the amount of effort put on the steering wheel, right? If it feels that little amount of effort is provided, so then it will accordingly supply the fluid to the uh, power double acting cylinders, power cylinders, right? So as I said earlier, it acts as the actuator itself, right? Here, these are the actuation paths, right? So these yellow color passages are belongs to left side, and green color passages are belongs to right side. So it will balance the pressure in left and right side. So if it is if we are giving uh, effort to the right side, so these left side chambers will be pressurized, right? So that amount is controlled by this torsion bar, right? So basically it will measures the amount of effort provided, right? So it's also a spool valve, right? You can see the spools are here, right? So these spools act as fluid passages, which will provide the fluid pressure as per the requirement, right? මේ passages වලට අවශ්‍ය pressure එක අර torsion bar එකෙන් limit කරලා දෙන pressure එක ඒකෙම sense කරලා මේ passages වලට අවශ්‍ය විදිහට වමටද දකුණටද කියලා දෙන්නේ ඔය valve එක. Right? And the everything that I discussed up to now regarding the rack and pinion power steering system is listed on the lecture slide, right? So you can go through and how it works, right? And here you have, I have included the actual cut section of rack and pinion. Here you have the integral, spool valve, which is connected to the steering column, steering shaft. And here the other end is connected to the pinion gear. And here we have the rack part. And yes, this is your double acting cylinder. Fluid lines, metallic lines are connected to both inlets and outlets, right? So based on the steering effort provided by the driver, this spool valve rotates with the limiting of the torsion bar provided here. Then based on that, the fluid comes from this pump will be directed to the this power cylinder, right? Not power acting, just power cylinder. Right? Any question up to now? My laptop, right? Where my screen is shared, right? Screen එක share කරපු එකේ account එකට යවන්න මම mobile එක දිහා බලන්නේ mobile එකේ voice විතරයි. Right, seems you don't have any questions up to now. So the external power steering, external linkage power steering system, the thing is that in here, you know that everything is combined in the rack part here inside. So in the external linkage power steering system, our double acting cylinder is located external. So that is the only difference, especially in off-road Jeeps and SUVs. The old SUVs are equipped with this external linkage power steering system, right? So the all other things are similar. The only thing is that we don't have integrated embedded cylinder like in the rack and pinion power steering system. Right. Then the second type, electronic steering assist, or we call it electric power steering, or simply EPS. Right. So nowadays we don't have hydraulic based steering systems, power steering systems. What we have is electric motor assisted power steering system. We don't have these hydraulic parts. The only thing is that here, the motor, right? The motor sometimes connected to the rack directly, rack shaft or steering column. So most common configuration is motor connected to the steering column, right? And I have seen that some of the very old vehicles which doesn't have power steering capabilities have been converted to power steering by connecting kind of this motor type of gear motors to the steering column, right? So that is a kind of aftermarket installation. Anyhow, the older vehicles are now having the capability of having power steering systems with the EPS, right? So hydraulic power steering. So the replication of hydraulic power steering system is not much easy as EPS, right? The best method is using EPS. Right? So it is not recommended, but EPS can be installed to any kind of vehicle by simply connecting this gear motor along with the feedback system to the steering column, right? What we have is a DC motor with the gearbox, right? Probably it will be a Bowman wheel gearbox, which will provide the higher uh, torque output at the gearbox end, right? So that I need to mention one thing, one additional thing actually. The power, as I said earlier, power steering is there to reduce the power, the effort provided by the uh, driver. So I repeat, power steering is there to reduce the effort provided by the driver, so that driver can smoothly handle the vehicle with less effort. And additionally, power steering is there to change the steering uh, effect and the effort actually, right? So I'm not sure whether you have experienced or not. So if you are driving a vehicle with power steering, doesn't matter, it may be hydraulic or electric. So power steering system is there to uh, change the power steering effort based on the vehicle speed, right? So what do you think? So suppose you are driving at 20 kilometers per hour and same vehicle 100 kilometers per hour, right? Here I'm going to consider two cases. The first one is lower speed, 20 kilometers per hour. The second one is 100 kilometers per hour, probably in highway, right? So, what do you think about the power steering or steering effort? Which one is higher, or which one is lower, or do we have similar effort? So, at higher speed, actually, at higher speeds, uh, the steering effort is higher, right? So if we don't have power steering at higher speeds, the steering effort may be lower, right? But with the power steering system, actually it limits the, or it will control the steering effort, right? The primary function is reducing the steering effort, but you know that whenever we are driving in a highway at higher speeds, a little steering change, little steering angle change will be a reason for some sort of higher turns, right? So that to avoid that, whenever vehicle speed increases, the power steering system uh, increase the steering effort by itself, right? Which means at lower speeds we can turn the vehicle with very less effort. අපි අඩුවේගකින් යද්දී power steering system එක. So I'm mainly referring to the EPS, right? I'm mainly referring to the EPS. So the EPS is having the kind of separate ECU. That ECU will send a signal that now the vehicle speed is lower, right? So they reduce the steering effort by providing higher torque to the wheel, right? But in highway speeds, the motor torque will be reduced just to maintain unique or uniform direction by tightening the steering system. එහෙම නැත්නම් අර highway එකේ යද්දී පොඩි steering change එකක්, ඒ කියන්නේ less effort එකකින් ඔකේ steering angle එක වෙනස් වෙන්න පුළුවන්. එහෙම වුණොත් පාර වෙනස් වෙනවා. අර straight කෙලින් තියාගෙන ඉන්න steering effort එක වැඩි කරලා දෙනවා EPS එකෙන්. Which means that electronic power steering. In electronic power steering, ECU takes the signal even from the wheel speed sensors, right? So those things will be discussed in modern automotive technology or automotive electronics. I'm not sure what is the exact module, but that EPS systems will be discussed in your future semesters, right? Right, then we have reached to the final part, steer by wire. Nowadays, we have drive-by-wire systems where we don't have any mechanical linkages in between the steering wheel and the steering gears and the wheels, where we have the connection using wires or signals or electronic signals. That here you can see that the steering wheel is connected to the sensor that determines the amount of effort and the amount of the angle which the steering wheel has been rotated, that it will send to the control unit ECU. Then ECU will send a signal to the power steering motor or steering motor here. Then the steering motor will rotate the wheel angles, right? So that we don't have any direct mechanical linkage or connection in between a steering wheel and the motor, right? Not the motor gearbox, right? So there's no direct connection. Yes, that's all for steering wheel, steering automobile steering system, not wheel, right? Steering system. Any question up to now? I think we have covered a lot of parts during this entire semester. So this is the last lecture actually. We have discussed about initially the engines, different construction of the engines, different types, and diagnostic and the repair part, and some special systems like engine cooling, oil circulation, fuel system, ignition, then gearboxes, manual transmission, automatic transmission, and wheels and differentials, right? So even I can't remember that the each and everything regarding the drivetrain was discussed, and then air conditioning, so and heating ventilation part was discussed, and braking, both hydraulic and air braking system was discussed, and suspension, all the suspension parts, and especially the stabilizer bar and how stabilizer bar prevents oversteering and understeering. Things were discussed, and tire designation, tire pressure, tire sizes were discussed. Right. So please notify me if I have missed anything, right? මම content එක කියාගෙන යන්න අපි cover කරපු. Then what else? We start the steering part today, and Vimukti sir, I think he covered the starting ignition part. Right. That's all. That's all for automobile technology lecture series. So I need to mention one thing regarding your exam. It will be on next week, or I think it will be on next week, right? So anyway, I'm not sure. Nalin sir will share you the timetable. Regarding the exam, that exam divides into two: continuous assessments and final exam. So I have given more than 4 continuous assessments, I think. So I'm going to consider only 3, right? So I'm going to consider only 3, so that you don't need to worry about if you have missed any continuous assessment. Then I'm going to consider maximum 3 marks, right? So then final exam will be a 3-hour exam since this is a 2 credit subject. I will give you 20 MCQs plus 6 essay questions. So you can select any 4 essay questions to write the answers. So 20 MCQs are compulsory. So from my part, you will have 15 or 16 MCQs. So based on that, Vimukta sir will include 5 or 4 MCQs. Similar for essay part, I will include 5 essay questions, right? I will include 5 essay questions and Vimukta sir will include 1 essay question based on the things that he discussed during the lecture, right? Yes, that's all. That's all from my end. And any question up to now? And Sanuka requested model paper. So I'm not going to give you a model paper since you have more than 4 past papers. So the past papers are the model papers here, right? I have uploaded all the lecture slides to the VLE. You can access. If you can't, please notify. That's all. If you don't have any questions, then let me wind up the session. And I will share the lecturer evaluation form shortly. Please be kind enough to fill the form, right? So actually, I didn't receive the evaluation form yet. So once I receive the form from the department, I will share you, right? Yes.